All right, hey, Math 20-2. Just want to show you guys, or remind you guys from Math 10, the difference between mixed and entire. Oh, why can't I write? Oh, there we go. And entire radicals. Um, so an entire radical just pretty much means it's entirely under the radical symbol. A mixed radical is like a mixture. It's got one like under and one not under. So yeah, that's pretty much it. So the first one here, write each of the following as an entire radical. So that means I want everything under the radical symbol. So the way we're going to do that is first thing you got to do is you got to check to see what the index of this is. What I mean by index again was is this a 2, which it is. Is it a 3, a 4, or whatever? So this is just a square root, so it's like it's a 2, right? Square root, there should be like a kind of hidden 2 right there. So then, since I know it's a square root, what I'm going to do is I need to get this 3 inside there. And the way you get it inside there is by squaring it. We're going to do the opposite of what the symbol is. The symbol is a square root, so we got to square this to put it back inside. So I can put this inside as long as I square it. So I'm going to rewrite this as 3 squared on the inside times 2, which is really the same as 9 times 2. So the answer for this one is square root of 18. All right, I'm not going to say too much more about those because I think I made my point. I want you guys to try them. The only other thing I think you guys might be a little bit confused about, if it's like to the like a fourth root, something like that. Again, the same thing holds. What we have to do is just do the opposite. So if it was a fourth root, we need to say 3 to the power of 4 if we're going to put it under there. So you'd say square root 3 to the power of 4 times 7. I'll let you guys figure out what that is. Yeah, so go ahead and do the rest of those questions there. Now, going the other way, right is a mixed radical. So now what we want to do is take stuff out. I find this is usually a little bit tougher, but still not too bad. Okay, the way we want to do these is if we're doing a square root, what we got to figure out is our perfect squares. So you guys have the perfect squares written on your formula sheet, but here they are again. So my perfect squares are, well, 1 times 1 is 1, so 1's a perfect square. 2 times 2 is 4, so 4 is a perfect square. 3 times 3 is 9, and then 16, 25, 36, 49, and so on. So these are our numbers that we're looking for when we're doing this stuff. So the first one here, 32, I'm going to go through and say, okay, do any of these numbers, my perfect squares, do any of those multiply into 32? If you're a little unsure and you can't just do it like just off the top of your head, what I'd like you to do is grab your calculator. You guys are all impressed when I pulled this out, aren't you? Grab your calculator. And what we want to do is say, okay, 32, I want to break this into 2 numbers. So, and I want them to be one of my perfect squares over here. So I'm going to say, well, 32 divided by, and I'm going to try my perfect squares. So divided by 4. And that gives me 8. So apparently 4 times 8 is 32, if you didn't know that one. So what I'm going to do is rewrite this as, instead of square root of 32, I'm going to write this as 4 times 8. And the whole reason that I did this was because now that I've split this up into 4 and 8, and 4 is a perfect square, I don't need 4 to be underneath the square root symbol anymore. What I can do is I can take it out now, but when I take it out, I need to take the square root of it. So when I take it out, it's going to be the square root of 4, which is 2. So this turns into 2. The 8 is still inside. The 4 got moved out, but the 8 is still there. So 2 times the square root of 8. All right. Yeah. So again, we'll try 48. So if you're not unsure of how what things go into 48, I'd maybe go 48, and I'm just going to try divided by 4 because that's my first one. And yeah, 12 is. But what about, well, let's do it this way. I'm going to show you guys, even if you get 4, there's a bigger one that goes into it, but we can do it we can do it this way no matter what. So I'll show you how that works. So 48, I'm going to rewrite this as 4 times 12. So again, now I've got a perfect square, 4, underneath the square root symbol. So I can take this out. This can now come outside the square root symbol, but when I take it out, I have to take the square root of it. So that's going to be now 2. Square root of 4 is 2. And what's left is 12. But the only problem here, though, is we chose a small perfect square to multiply by. We could have also chose 16, which we could have done this in one step, but we didn't. So the other thing we can do now with 12 is I know that 12 could also be written as 4 times 3. So now that it's 4 times 3, I know the square root of 4, so I'm going to bring it out as well. So the square root of 4 is 2. So now, I'm just going to write this up here. We've got a 2 that was already out there. We've got a new 2, so this would kind of look like 2 times 2, and then that square root of 3 is still in there. So 2 times 2 is 4. Square root of 3. So that'd be the answer for that one. So this is a good introduction that if something is out front of the square root symbol, you just need to, whatever you bring out, you just need to multiply by that. You're going to have the same kind of situation here. So whatever you bring out of your radical is going to be multiplied by 3. So just make sure whatever you pull out, you multiply by whatever's already out there. The other thing to keep in mind is cube roots. So if this thing has a cube root, or these ones have like a fourth root, we can't use our perfect squares anymore because we don't really care about perfect squares now. We care about perfect cubes. So our perfect cubes would be, well, the first one would be 2 times 2 times 2, right? So 8. Next one would be 3 times 3 times 3, which is 27. The next one's going to be 4 times 4 times 4, which would be 64. And I'm starting to see something that looks something like we can use, 64. Because if I look at this, 128, well, I can rewrite this as, I'll leave the 2 out there, cube root this time. I can rewrite 128 as 64 times 2. Well, I know what the cubed root of 64 is. It's 4 times 4 times 4. So remember, 4 cubed was equal to 64. So it's just going to be 4. I can bring a 4 out. So when I bring that 4 out, it would just end up being 2 times the 4 that's now out there. Cubed root of 2. 2 times the 4 that was already out there. This is just 8 cubed root 2. I'll let you guys work on the rest of those. Oh, that one should be easy for you now. Yeah. So moving on down, really, I think we just need to practice a lot of these. So I've got some matching for you. So just match whatever the answer or whatever the answer for this is over to this side. Probably a little hint is that if you have a cube root, it's probably going to go with one of the cube root ones. Just saying. All right, that's all I'm going to say for this video. I'll see you guys in class.